transformation of the periodic function. Now the periodic function we have studied in our first sum. You first hear the periodic function. What are the periodic function? So we can say the periodic function, if a function which is the period alpha, if the function gets the same values after n time iteration, यानी f(x plus alpha equals to f(x) for all n की वैल्यूज के लिए f of x plus n alpha equals to x, then the function f(x) is said to be the period of alpha. alpha इसका period है क्योंकि वो alpha के बाद जब alpha टाइम alpha इसमें ऐड हो रहा है तो अपने आप को रिपीट कर रहा है, तो रिपीटेशन ऑफ द फंक्शन आफ्टर द टाइम period alpha. Now what is the Laplace transformation of the periodic function? अगर हम बोले कोई फंक्शन f(x) भी हमें गिवन है, इसका जो पीरियड है वो हमारे पास अल्फा गिवन है, विद द अल्फा, देन क्या होगा f of x प्लस n अल्फा मस्ट इक्वल टू f of x for all n. Then the Laplace transformation of this function, ये जो पीरियडिक फंक्शन है हमारा f(x), इसको हम f(x) भी लिख सकते हैं क्योंकि n अल्फा इक्वल्स टू f(x) ही है. तो दिस इज इक्वल्स टू 1/1 माइनस e raised to the power माइनस p अल्फा 0 to अल्फा e raised to the power माइनस px f of x dx. तो लाप्लास ट्रांसफॉर्मेशन ऑफ द फंक्शन f(x) जो कि हमारा पीरियडिक फंक्शन है विद पीरियड अल्फा, then the Laplace transformation of this function f(x) is given by 1/1 minus e raised to the power minus p alpha 0 to alpha e raised to the power minus px f of x dx. ये आपको फॉर्मूला है, ये याद करना है. अब एग्जांपल लेते हैं, इसको निकालते हैं कि कैसे आता है. नाउ लेट हमें कोई फंक्शन है f(x) जो कि पीरियडिक है, इसकी वैल्यूज हैं sin x and 0 is less than pi, 0 then pi is less than x less than 2 pi. ये फंक्शन आपको f(x) है, ये गिवन है. ये फंक्शन f(x) इक्वल्स टू दिस फंक्शन इज अ पीरियडिक फंक्शन विद द, इसका पीरियड क्या दिया हुआ है आपको, अल्फा है, alpha is 2 pi with the time interval 2 pi. The function is defined as the interval 0 to pi the function gets the value sin x, and interval pi to 2 pi the function is 0. Then we have to find the Laplace transformation of f of x, Laplace transformation of this f of x p. Since the function f(x) is given, it is periodic function with the period alpha. So what should, applying the formula 1 minus e raised to the power minus p alpha is what, 2 pi 0 to alpha is again 2 pi e raised to the power minus px f of x dx. ये हमारा फॉर्मूला सॉल्व कर देंगे. 1 minus e raised to the power minus 2 pi p 0 to pi, here the integral is breaking at 2 points, pi 0 to pi and pi to 2 pi, so in the 0 to pi the function get the values, this is e raised to the power minus px, the function get the value sin x dx, and the limits are pi to 2 pi, the function get the value 0. Then this part of the integration becomes 0, and this is e raised to the power minus ax sin bx. Applying the formula of integration, this is our 1/1 minus e raised to the power 2 pi p. Now this is 0 to pi e raised to the power minus ax sin bx dx. Then what is the formula of this? This is e raised to the power minus ax, which is px over a square plus b square. Here a is what, p square, and b is what, 1 into a sin x. A is what, minus p sin x minus b is 1 cos of x. The interval is 0 to pi. This is our formula. Applying this, now putting the values of x equals to pi and 0, 1 upon 1 minus e to the power minus 2 pi p. P square plus b is again independent of x, so it is also outside of the limits. Now we put here pi, this is e to the power minus p pi, this is minus p, sin of pi is 0, minus cos of pi is 1 minus, I am putting this e to the power minus px which is 1, p minus p sin of 0 is 0, minus cos of 0 is 1, so this is minus of 1. What is it here? 1 upon p square plus 1 minus e to the power minus 2 pi p e to the power minus, this is minus p into 0, this is e to the power minus p pi, this is minus plus 1 can be written as 1 plus e to the power minus p pi, this is 1 minus e to the power minus 2 pi p, it can be written as a square minus b square, which is a plus b into a minus b, so it simply can be as 1 upon p square plus 1, this is 1 plus e to the power minus 5p, 1 minus e to the power minus 5p, and further हमारे पास e to the power minus 5 plus 1, this is cancel out to the integration value of the Laplace transformation of the, we get here 1 upon p square plus 1 into 1 minus e to the power minus p pi. क्लियर है? ऐसे हम अगर आपको पीरियोडिक फंक्शन गिवन होगा, विद फंक्शन पीरियोडिक डिफाइन होगा, तो आपको पीरियोडिक फंक्शन का फॉर्मूला लगाना है. नाउ दे आर टू इम्पॉर्टेंट फंक्शन. फर्स्ट इज यूनिट स्टेप फंक्शन और हेविसाइड यूनिट. If a function denoted by h of x minus a, this is defined as 0 when x is less than a, 1 when x is greater than a, then the function defined by this is called Heaviside function, Heaviside unit function or unit step function. H of x minus a is defined as 0 when x is less than a and 1 when x is greater than a. This is the unit Heaviside function. Now we have to find the Laplace transformation of this h of x minus a. So applying the basic property of the integration, what is our Laplace transformation? A to the power minus px f of x, what is it? H of x minus a dx. Now the function h of x minus a is defined as 0 when x is less than a and 1 when x is greater than a. So the integration is defined between 0 to a e to the power minus px. Here the integration is the value 0 dx and a to infinity e to the power minus px. Here the integration h of x minus 1 has the limit value 1. This integration becomes 0 due to multiplying by 0. This is just a to infinity e to the power minus px dx. Integrating it, we will get a e to the power minus px over minus p, and we can p, the value is a to infinity. Now this is putting the value limits here. This is when x tends to infinity, from original limit x tends to infinity 1 upon p e to the power minus px minus 1 upon p. Putting x equals to this is minus of ap minus minus, this is plus, this is a minus sign. Now we know that the function is Laplace transformation of a function is of exponential order of Lp when p is greater than 0. So using the existence condition of the Laplace transformation of the exponential order of p, this integration becomes 0, and the Laplace transformation of Heaviside unit function h of x minus ap is e raised to the power minus ap over p. It is clear? तो इसे फाइंड करने में तो कोई दिक्कत ही नहीं है. यहाँ सिंपली हमें यहाँ पे हेविसाइड यूनिट फंक्शन क्या है ये याद रखना जरूरी है. अगर हमें ये ही नहीं पता कि फंक्शन क्या है तो हम इसका लाप्लास ट्रांसफॉर्मेशन नहीं फाइंड कर सकते. तो यहाँ आपको एच ऑफ एक्स माइनस ए, इसको यूनिट स्टेप फंक्शन भी बोलते हैं और हेविसाइड यूनिट फंक्शन भी बोलते हैं. तो ये आपको पता होना चाहिए. अगर आपको ये फंक्शन याद है तो आप यूजिंग द लाप्लास ट्रांसफॉर्मेशन बेसिक डेफिनेशन वी विल फाइंड द लाप्लास ट्रांसफॉर्मेशन ऑफ द हेविसाइड यूनिट फंक्शन व्हिच इज we will find this to the power minus ap over p. Now there is one important function, it is called unit impulse function or Dirac delta function. सबसे पहले तो हम ये जानेंगे कि what is Dirac delta function, how we define the function Dirac delta. Let be a function f of epsilon x which is defined as 1 upon epsilon when 0 is less than x is between the values 0 to epsilon. This is epsilon and 0 when x is greater than epsilon. अगर कोई फंक्शन हमने ऐसा डिफाइन किया है f of epsilon x such that the function get the values 1 upon epsilon when 0 is less than x is less than epsilon and 0 when x is greater than epsilon. यदि हम इसका ग्राफ ड्रॉ करें, this is the x, this is our f of epsilon x. तो then the value of 0, अगर x की वैल्यू ये पॉइंट अगर हमारा epsilon है तो x की वैल्यू जिस epsilon है तो ये वैल्यू कोई 1 upon epsilon गेन करेगा. This must be 1 upon epsilon. And for greater than epsilon this is 0. So this is such kind of graph. 0 to epsilon function f of x is equals to 1 upon epsilon. This value must be 1 upon epsilon. And when x is greater than epsilon f of x की वैल्यू 0 है. तो ऐसा अगर हम इसको ग्राफिकली डिनोट करें तो हम इस फंक्शन को ऐसे डिनोट कर सकते हैं. If this function is defined as, then the Dirac delta function is defined by delta x such that limit of y tends to 0 f of xi x exists. अगर हम इस एप्सिलॉन से एप्सिलॉन बोल लो xi जो भी whatever you want to call, limit epsilon tends to 0 f of epsilon x अगर ये लिमिट एग्जिस्ट करती है then this is noted by delta x which is the function Dirac delta function. Now we will find the Laplace transformation of this Dirac delta function. So we can write that Laplace transformation of this f epsilon x p is what? Applying the basic definition 0 to infinity e raised to the power minus px f of epsilon x dx. Now you know our function f of epsilon is defined as 1 upon epsilon and 0 is less than x is less than epsilon and 0 when x is greater than epsilon. This is our f of epsilon x. Putting this here 0 to epsilon raised to the power minus px 1 upon epsilon dx plus epsilon to infinity raised to the power minus px. Here our function is 0. Now this integral vanish. Now this is what 1 upon epsilon integrating this e to the power minus px over minus p 0 to epsilon can be written as minus 1 upon p epsilon and putting here epsilon this is e to the power minus p epsilon minus 0 this is 1 1 t minus ny, so it is this is equals to 1 minus e raised to the power minus p epsilon over p epsilon. This is our Laplace transformation of f of epsilon x p. Now this is not the Laplace transformation of the Dirac delta function. This is the Laplace transformation of f epsilon x p. Now we know that our Laplace Dirac delta function del x is defined as limit epsilon tends to 0 f of epsilon x. अगर ये लिमिट एग्जिस्ट करती है तो हम इसको डेल्टा एक्स से डिनोट करते हैं. तो नाउ वी कैन राइट एज टेकिंग लिमिट epsilon tends to 0 Laplace transformation of f of epsilon x p, which is equals to limit of epsilon tends to 0 1 minus p epsilon over p epsilon. Here applying the DL rule, differentiating with respect to epsilon, तो ये क्या हो जाएगा? This is limit epsilon tends to 0. फर्स्ट टाइम ये करेंगे इट इज epsilon के सूत्र में तो प्लस p raised to the power p epsilon over p. Now putting here epsilon tends to 0. This is what 1 can be written as limit epsilon tends to 0 Laplace transformation of this f of epsilon as p is equals to 1. Now we know that our Laplace transformation of linear, so using that the linear property of the Laplace transformation, we can write this as Laplace transformation of limit epsilon tends to 0 f of epsilon x p is to 1, which is Laplace transformation of Dirac delta function del x defined by 1. Clear है? Laplace, this is the limit epsilon tends to 0 Laplace transformation of f epsilon x p is 1. Then taking this inside, since our Laplace transformation is linear, so it can be inside Laplace transformation of limit epsilon tends to 0 f of epsilon x, which is del f. This is what our Dirac delta function. We can write as Laplace transformation of Dirac delta function is 1. Now if I say find the Laplace transformation of del of x minus a, हमें Laplace transformation of del of x minus a p फाइंड करना है. तो ये del x minus a ये क्या है हमारा? बेसिकली दिस इज द Dirac delta फंक्शन. तो Dirac delta फंक्शन को हम कैसे डिफाइन करते हैं? del of x इज व्हाट? limit epsilon tends to 0 f of epsilon x. So we can write here del of x minus a is what? Limit epsilon tends to 0 f of epsilon x minus a. Now we have to define the function f of epsilon x minus a. f of x minus a is what? We know our f of epsilon x function is how defined? We define it by 1 upon epsilon when 0 is less than x is less than equals to epsilon, and 0 when x is greater than epsilon. So here putting x minus a, so it is what? 0 when x is less than a, 1 upon epsilon when a is greater than x is a plus epsilon, and again 0 when the values of x is greater than a plus epsilon. If we replace here x minus a, so this is 1 upon a x minus a, तो इसको पुट करके आप इसे निकालेंगे तो ये आ जाएगा. तो जो हमारा फंक्शन है f of epsilon x minus a is defined by 0 when x is less than a, 1 upon epsilon a to a plus epsilon, and 0 when x is greater than a plus epsilon. Now we will take the Laplace transformation of this function. which is what? So here you have to find the Laplace transformation of this f x minus ap, which is what? 0 to infinity f of epsilon x minus a e to the power minus px dx. Now the limits is breaking at 2 points into 2 intervals. So here the value from 0 to a, the function gets 0 e to the power minus px dx. Then a to a plus epsilon, the function get the value 1 upon epsilon e to the power minus px dx, and the function is greater than a plus epsilon to infinity. Function get again 0 e to the power minus px dx. Now this integral is vanished and this integral is vanished. We have only 1 upon epsilon e to the power minus x to the power minus px over p, and a2 a plus epsilon. This is what combined 1 upon p epsilon a plus epsilon. This is e to the power minus p a minus p epsilon. We will put it, take a minus and outside, minus e to the power minus ap. P a plus epsilon, this is p a minus p epsilon. So here this is common. So e to the power minus ap or p epsilon into minus sign and the side then 1. This is minus plus 1 minus e to the power minus p epsilon. This is the Laplace transformation of the f of epsilon x minus a. Laplace transformation of f of epsilon x minus a. Now if we take here limit epsilon tends to 0 both sides, this is limit epsilon tends to 0 x to the power minus ap or p epsilon 1 minus e to the power minus p epsilon. Now applying the real process, this is independent of epsilon, this term is outside, this is then applying the real hospital rule. Here this is what? Minus p, this is p e to the power p epsilon over 1. Limit of epsilon tends to 0. This becomes epsilon tends to 0, 1. This is e to the power minus ap. This is p से p cancel हो जाएगा हमारा. This is 0, 1 e to the power minus ap. Now this epsilon can be no longer. Making this inside using the negative property of the Laplace transformation. This is f of epsilon x minus a p, which is defined as Laplace transformation of del of x minus a p is equals to e to the power minus ap. Now here today we have finished our Laplace transformation. Now in the next class we will study about the inverse Laplace transformation. So to move further, we have to remember that in the inverse Laplace transformation we have to remember all the basic formulas of the Laplace transformation of the all type of the function x and e to the power x, sine hyperbolic, cos hyperbolic, sine and cos. So you have to remember all these formulas to further go in our syllabus inverse Laplace transformation. Okay, thanks.